Honda has reportedly reached a crucial Aston Martin engine milestone earlier than expected, and the timing could hand the team something every Formula One rival desperately wants: more development time. Reports dated July 22nd and July 26, 2026, claim Aston Martin's new Honda power unit was signed off early. But the available source does not reveal the exact upgrade, the approval timeline, any performance figures, or a direct Honda statement explaining what changed. And that missing detail is exactly why this matters. Because early approval does not automatically mean more horsepower, it can mean something even more valuable. More time to test reliability. More time to improve cooling. More time to integrate the engine with the chassis. And more time to discover weaknesses before Aston Martin's rivals ever see the finished car. If Honda has genuinely cleared a major development stage ahead of schedule, Aston Martin may have gained an advantage that cannot be copied overnight. But the biggest revelation is not simply that the engine was approved early. It is what Honda and Aston Martin can now do with the time they have gained. Subscribe to the channel. To understand why this early milestone could matter so much, you have to look at the part of Formula One development most fans never see. Time. Not lap time. Development time. The source only confirms a headline-level claim that Aston Martin's new Honda power unit was signed off early, with reports dated July 22nd and July 26, 2026. It does not reveal the exact component, the approval process, or how far ahead of schedule the program may be. But even without those missing details, the potential value is enormous. A Formula One power unit is not simply an engine placed inside a finished car. It influences almost everything around it: cooling, weight distribution, electrical systems, rear-end packaging, bodywork, aerodynamics, and even the way the driver feels the car when applying the throttle. Every one of those areas is connected. Change one, and the others may need to change with it. Imagine designing an entire kitchen before knowing the exact size of the oven. You can make estimates. You can leave extra space. You can prepare several possible layouts. But every decision includes uncertainty. Then the final dimensions arrive earlier than expected. Suddenly, the cupboards can be placed properly. The electrical system can be finalized. The surrounding space can be used more efficiently. That is the possible advantage Aston Martin may have gained: clarity. And in Formula One, clarity allows engineers to stop protecting themselves from several possible futures. They can begin committing to one. That does not guarantee the fastest car, but it can prevent the team from losing precious time while waiting for answers. And here is where the situation becomes more interesting. The engine and the car cannot be developed as separate projects. Honda may create a powerful and reliable unit. But if Aston Martin cannot package it efficiently, part of that advantage disappears. A power unit may need more cooling. More cooling may require larger openings in the bodywork. Larger openings can disturb the airflow around the car. And disturbed airflow can reduce aerodynamic performance. So even a stronger engine can create a slower complete package if the integration is poor. That is why early information matters. It gives Aston Martin more time to understand the trade-offs. How much cooling does the power unit need? Where can the components be placed? How tightly can the rear of the car be packaged? How does the weight affect balance? And how will the power delivery influence the rear tires? Those questions cannot be answered properly at the final moment. They need testing, comparison, failure, correction, then more testing. That process is where early progress can become real performance. But there is an important warning. Signed off does not mean finished. It does not mean Honda has created the strongest power unit. It does not mean every reliability concern has disappeared. And it does not mean Aston Martin has already gained an advantage over every rival. The source does not provide any data supporting those conclusions. What it may suggest is that one major stage has been completed earlier than expected. and completing one stage early can open the next stage sooner. That is the real opportunity. More time to test how the power unit behaves under heavy load. More time to study heat. More time to understand vibration. More time to improve energy deployment. And more time to discover whether a design that looks strong in controlled conditions can survive the punishment of a full Grand Prix weekend. Because the test bench and the racetrack are not the same thing. On a test bench, engineers control the environment. On the track, everything changes. The temperature changes. The grip changes. The driver changes the demand from corner to corner. The car hits curbs. The rear tires slide. The power unit heats up. Then it cools. Then it heats up again. A system that works perfectly once must work repeatedly, lap after lap, session after session, race after race. That repetition is what creates reliability. And reliability changes how aggressively a team can use the power. A powerful engine means very little if the team is afraid to push it. If temperatures rise too quickly, performance may need to be reduced. If components are under too much stress, the driver may be told to manage. If energy deployment is inconsistent, the car may feel strong in one part of the lap and weaker in another. That can damage confidence. And confidence is critical when the driver is trying to accelerate out of a corner at the limit. The power must arrive in a way the driver can trust. Not too suddenly. Not too late. Not unpredictably. Usable power matters more than a dramatic number. And this may be where Aston Martin's partnership with Honda becomes so important. The strongest possible outcome is not Honda building an engine, then asking Aston Martin to fit it into the car. The strongest outcome is both organizations designing the complete package together. Honda understands what Aston Martin needs. Aston Martin understands what Honda requires. Information moves quickly. Problems are shared early. And one department does not solve its own issue by creating a bigger problem for another. That sounds obvious. In reality, it is incredibly difficult. The power unit engineers may want more space for cooling. The aerodynamic engineers may want tighter bodywork. The chassis team may want better weight placement. The reliability group may want safer operating limits. The performance group may want everything pushed harder. Each side has a valid argument. But the car can only follow one final direction. That is where early sign-off may help. It may give Aston Martin more time to study those conflicts before they become expensive. A late problem forces a rushed solution. A rushed solution often adds weight, reduces flexibility, or damages performance somewhere else. An early problem creates options, and options are valuable. The team can compare several solutions. It can test different layouts. It can reject weak ideas before manufacturing begins. It can solve the cause instead of hiding the symptom. But this is only valuable if the early direction is correct. That is the risk nobody should ignore. An early sign-off can create confidence. It can also lock the project into a decision. Once the car is designed around a certain power unit layout, changing direction becomes much more difficult. Other systems depend on it. Parts are produced around it. The aerodynamic concept begins adapting to it. So finishing early is not automatically good. Finishing the right design early is good. The source does not tell us enough to judge that. It does not reveal the testing results. It does not provide reliability figures. It does not show power data. And it does not explain what Honda reportedly approved. That means the biggest conclusion must remain open. Honda may have created a valuable time advantage. Or Aston Martin may simply have completed one planned stage while the hardest work still lies ahead. And that distinction matters, because Formula One projects are rarely defeated by one obvious failure. They are often defeated by small compromises that connect. A cooling demand affects bodywork. The bodywork affects airflow. The airflow affects tire performance. The tire performance affects the driver's confidence. The driver's confidence affects lap time. One hidden issue spreads through the entire car. That is why Aston Martin cannot celebrate the engine milestone in isolation. It has to ask what the milestone unlocks. Can the car become more compact? Can the cooling system become more efficient? Can the weight be placed more effectively? Can the power delivery protect the rear tires? Can the team spend more time improving performance instead of solving basic integration problems? Those are the questions that will decide whether the early sign-off is truly huge. And the answer will not come from the date on an internal approval. It will come from what happens next. Because Aston Martin may now possess the most valuable resource in modern Formula One. Not guaranteed speed. Not guaranteed reliability. Time to discover the truth before the rest of the world sees the car. And this is where the possible advantage becomes much harder to copy. A rival can study a visible aerodynamic idea. It can photograph the bodywork. It can examine the shape of the floor. It can compare how the car behaves through a corner. But it cannot immediately recreate months of extra preparation. Time is invisible. And when a team uses it well, the result only becomes obvious much later. That is why an early engine milestone could matter far beyond one technical department. If Honda has truly completed an important stage ahead of schedule, Aston Martin may be able to begin the next phase while rivals are still managing uncertainty. But the available source does not confirm the size of that lead. It does not explain the exact milestone. It does not provide a direct statement from Honda. And it does not include any measured performance data. So the scale of the advantage remains unknown. What can be understood is the opportunity. More time allows the team to ask better questions. Not only does the power unit work, but how well does it work with the complete car? Can the cooling system remain effective in hot conditions? Can the electrical energy be delivered consistently through an entire lap? Can the driver attack without being told to protect temperatures? Can the rear tires survive the way the power arrives? And can all of that happen without sacrificing aerodynamic performance? Those questions are where a promising engine becomes a successful Formula One package. Because raw power is only one part of the story. The driver does not feel a number on a screen. He feels the car. He feels whether the power arrives smoothly. He feels whether the rear tires remain stable. He feels whether the response changes as the temperatures rise. And he feels whether he can trust the same behavior lap after lap. That trust is critical. A driver who trusts the power delivery can apply the throttle earlier. He can commit more confidently. He can use the car's performance instead of protecting it. But if the response is unpredictable, even a powerful engine can become difficult to exploit. Imagine turning on a tap that delivers water differently every time. Sometimes the flow is smooth. Sometimes it arrives too strongly. Sometimes it is delayed. The supply may be powerful, but it is not easy to control. A Formula One driver faces a similar problem when the power delivery lacks consistency. The car may have performance, but the driver cannot use all of it naturally. That is why Honda's work would have to go far beyond creating maximum output. The power must be usable, predictable, efficient, and repeatable. An early milestone may create more time to refine those qualities. But this is where Aston Martin's role becomes just as important as Honda's. The engine can only perform inside the environment the car creates. If the car cannot cool it effectively, the team may need to reduce performance. If the packaging creates too much weight in the wrong place, the balance may suffer. If the bodywork becomes too open, aerodynamic efficiency may be lost. And if the complete system becomes too complicated to operate, small problems can become race-ending failures. That is why the partnership has to work as one organization. Honda cannot simply deliver a power unit. Aston Martin cannot simply build a chassis around it. Both sides have to make decisions together, early, clearly, and without hiding problems. That last part matters more than it sounds. Large engineering projects can become dangerous when teams protect good news and delay bad news. A cooling concern is described as manageable. A weight target is described as close. A reliability issue is described as temporary. Each statement may sound harmless,